Hey everyone, today we're going to continue on with our thermochemistry chapter, and we're going to talk about the first law of thermodynamics today. Before we can talk about the first law of thermodynamics, we have to understand some major vocabulary terms, and that is identifying the difference between a system and surroundings. So, when analyzing energy changes, we want to focus on a limited and well defined part of the universe. And that's because the universe is so big, we want to be able to keep track of the energy changes that we're focusing on. The system is actually defined as the portion of universe that we're looking at or singling out to study. The surroundings is everything that lies outside of the part that we are studying. So, an example of this is when studying energy changes for chemical reactions, our system is going to be the reactants and products that we are using. The container and everything beyond it could be the surroundings. Now, in terms of systems, there are three different types. There are open, closed, and isolated. An open system is honestly the most common one. This is where matter and energy can be exchanged with the surroundings. An example of this is an uncovered pot of boiling water. When you boil water, it can escape as water vapor into the atmosphere. So you're losing matter, and then also energy is being exchanged. Energy is being switched from the stovetop into the pot. A closed system, on the other hand, is where energy is still allowed to be exchanged, but matter is not. So this is like putting a lid on a saucepan with, let's say, pasta sauce being heated up. The lid must stay on in order to be a closed system. The pasta sauce isn't being exchanged, so matter's not being exchanged with the surroundings. However, energy still is. You can still heat up that sauce, it's still taking in the energy from the stove. An isolated system is where neither energy nor matter can be exchanged with the surroundings. Isolated systems are very, very hard to get because there is some loss of energy. However, insulated thermos containing hot coffee is the best example as long as the lid stays closed. The lid's closed, hot coffee cannot leave or enter, so it's isolated in terms of matter. And then it's very good at not exchanging energy either. The heat in the thermos stays in the thermos. Now that we understand those two terms, let's go into the first law of thermodynamics. This law states that energy can neither be created nor destroyed, it can only be transferred or transformed. So, when I'm saying a loss of energy or a gain of energy, we're not creating or destroying it. What's happening is any energy that is being lost by what you're studying has to be gained by the surroundings, and vice versa. If you are gaining it, that means that the surroundings have lost it. And this ultimately means that energy of the universe is going to remain unchanged or energy is conserved. Because of this definition, the first law of thermodynamics is often called the law of conservation of energy. Now, speaking of energy, we're going to look at something called internal energy, which we denote as E. Internal energy is the sum of both the kinetic and potential energies within a system. However, in thermodynamics and thermochemistry, we are mainly concerned with the change in internal energy. So we usually denote change using the Greek letter delta, which is a triangle that means change in the energy. Now, with change in energy, these are quantities that have to have three parts. The first part is a number. So 84 right here is my number. The second one is a unit to give some kind of magnitude. In my example, my unit is J, which is joules. In the last lesson, you did learn that other units can include kilojoules, calories, or kilocalories. The last part, which is the part people often forget about, is we usually use a sign in thermodynamic quantities. The reason we use a sign is because it shows the direction that energy is flowing. Is energy flowing into the system or is energy flowing out of the system? We typically use positive and negative values to illustrate this concept. If you remember from the previous lesson, we defined energy as the capacity to do work or transfer heat. So when we're looking at a system and we're looking at the energy of it, it is shown two different ways, as heat or as work. It says when a system undergoes any chemical or physical changes, the change in energy is because one of these two values has changed. Delta E is the sum of heat, which is denoted by the letter Q. That means heat can be added to the system or removed from the system. And then it's going to add W, which stands for work. So work can be done on the system or it can be done by the system. So when heat is added to a system or work is done on the system, typically its internal energy is going to increase. When heat is removed or work is done by the systems, or if we say work is done on the surroundings, its internal energy tends to decrease. And these are two that I'm going to star because you kind of have to understand this concept. Your book that I teach out of gives the following table to kind of tell you positive versus negative values. So again, if the system gains heat, we're tending to get a positive Q. If it loses heat, you get a negative Q. If work is done on the system, or sometimes we say by surroundings, we're going to get a positive value. If we say that work is done by the system, or we say on surroundings, that's going to be a negative value. And this overall is going to affect our change in E. Now, I am not going to give you this table. This is something that I will expect you guys to know for your test as a little heads up. So what exactly does that all mean, the positive and the negative? Well, remember, the positive and negative tells me the direction that heat or energy is flowing. So here, whenever we get a positive value for delta E, it typically means that energy has been gained from the surroundings, and so energy is flowing into the system. That's how we get that positive value, and we classify this reaction as endothermic. We have absorbed heat, absorbed energy. If you have a negative value because you have lost energy by either losing heat or doing work, we call this exothermic because all that energy is leaving the system. Exo as in exiting. Remember, if we have an increase in energy of our system, that means our surroundings is decreasing and vice versa. So here are some problems that we can work through. We're going to be using the equation change in E equals Q plus W. Remember, Q stands for heat and W stands for work. Our first one says, as a reaction occurs, the system loses 1,150 joules of heat to the surroundings, while the surroundings does 480 joules of work on the system. And I want to know what the change of internal energy is for the system. So while we are looking at this, and this is simple addition, we have to pay attention to the wording and making sure, does that value get a positive or negative sign? The other thing that we really have to watch out for is make sure units are the same. So for example, if this is joules, my other one should also be joules. We want to make sure they're in the same units. So when we look at this, we have to read it. The system loses heat. So if we see losing heat gives a negative value for that. So if my system is losing heat, that is a negative 1,150. And then it says the surrounding does work on the system. So if I look at this, if work is done on the system, I get a positive value for that number. So this is plus a positive 480. When you plug that into your calculator, you find that the change of E actually is equal to negative 670 joules. I'm using joules because that is what unit we are using for our energy. Now, one thing I'm going to have you guys do is classify this as being endothermic or exothermic. Here you can look at the positive or negative. I have a negative sign, which means that this is going to be considered an exothermic reaction. For the next example, it says, calculate the change in the internal energy for a process in which the system absorbs 140 joules of heat from the surroundings and does 85 joules of work on the surroundings. So again, pay attention to the wording and make sure units are the same. So joules and joules, units are good. It says the system absorbs heat. So if you look at this, if you absorb heat, you're gaining heat, that value is going to be positive. So positive 140 plus, here it says it does work on the surroundings. So if work is being done on the surroundings, work done on surroundings, this is going to be a negative value. So here my negative value is negative 85. When you guys go to subtract this, 140 minus 85 gives you a difference of 55 joules. Note that this is a positive 55, so you can leave it as 55 or write the positive, either's okay. I am going to have you guys classify as endo and exo, and so this one would be classified as endothermic because of that positive charge. In terms of sig figs, here, if we are looking at it, we are adding, so it is based on place value. So you just have to make sure they have the correct number of place values and they're both fine. Here is some practice ones that you guys can do. When we look at these practice problems, it says the value of delta E for a system that performs 7,655 joules of work on the surroundings and releases 2,500 joules of work is blank joules. Is this reaction endothermic or exothermic? And then we have the problem below it. I highly encourage you guys to pause this video and see if you can do these two problems, and then unpause it and see if you get the correct answer. So here, when we're looking at this, I'm going to look at this and say it performs work on the surroundings. That means that this value should be a negative 7,655 joules. I'm going to add this to my 2,500. But because it says it's releasing heat, that's a negative 2,500. So when I actually add these up together, I get an overall total of 101.55 joules. Here, I'm just adding, I'm not too particular about sig figs on here for this problem. So if you put negative 101 55 joules, that is perfectly fine. If you said 102.00 joules, that is okay if you're doing by the addition. I'm okay. The next one, if you were to do this, you would see that it says it absorbs heat. So that is going to be a positive 9,500 joules. And then it says that 7,655 joules was done on it by the surroundings. So work was done on the system by the surroundings. That's also going to give us a positive value. When I add these together, you get 171.55 joules. And then here, I'm okay with you keeping it as this number. If you're one that's worried about sig figs, if you did 172,000, that is okay. Now, I also asked you to classify as endo or exothermic. Here, because of the negative value, this one is exothermic. Because here, this is positive, this is endothermic. Okay. The last thing we're going to talk about is something called a state function. State function is a property of a system that is determined by specifying the system's conditions or state in terms of temperature, pressure, and so forth. The value of a state function depends only on the present state of the function. We don't care about the path that it took to reach that state. For example, E is a state function. Work and heat are not state functions. And so the best example I can give you for that is here. Here, I have 50 grams water, and my temperature is 25 degrees Celsius because temperature is considered a state function. We don't care how we got to that 25. We just care about that 25. We don't care about the path. We don't care if we started at 0 and heated it up. We don't care if we started at 100 and cooled it down. We just care about, again, the current state, not the path. Okay, and that's the end of today's lesson. If you have any questions, please make sure you ask, and I hope you guys have a great day.